Hey guys, what's up? Code Talks here. Today we're gonna do math in Python. So how to do those simple math operators. These are basically the most kind of used ones. But I'll explain that. I'll just do it now. That when we get to the little more difficult kind of functions in the video, there are obviously more functions like Java and like C and all those languages that like you could do uh, operations with the constant e, logs, square, not squares, sines, trig ratios, and stuff like that. But these are probably the most common ones you'll use. Anyways, let's get into it right away. So addition, basically, I'm gonna actually at the start of this kind of script, I'm gonna create two variables. I'll create a and b. Sorry, a and b. Uh, for basically the basic math section. So sum, how do you add? Simple. Like all other languages, you just do add, and then you just we can just do print statement. The sum of a and sorry, b. I don't need a space. I put a space. And b is, I don't know why this computer is so laggy. Okay, is sum. Yeah, perfect. Subtraction. I'm just gonna call this variable diff. And again, in Python, you don't have to write the type or anything. You can just do um a minus b right away, and then we'll copy in our print statement, and we'll change this to diff. The difference between, okay, and divisions. I'll call this quote for quotient and do okay, this is gonna be an int answer, and this is gonna be a float answer. Okay, I just indented it so you can see a bit better, but like usually you wouldn't do that. Okay, so 5 divided by 2, not 5.2, 5 divided by 2. I'll call this, yeah, I'll call this I quote for like integer quote, I underscore quote, and then the next one I will call f underscore quote equals. Why did I do 5 2? I wanted to do a b. Okay, and then this I'm gonna do float a divided by b. Okay, and I want to print the quotients, and then I'll print out I quote, and I will print out f quote, not float, f quote. Okay, um, and then we'll do multiplication. Multiplication, simple. Use the asterisk. What do you call it? So I'll just call this prod for product. I asterisk b, and then print uh the. I'll just write product, and then print prod. Okay, let's run this. Line 20, what is up? Because this is tab for no reason. So yeah, code blocks is important. Honestly, I should not even do this. This is a bad habit. Okay. Oh, this is okay. Okay, this is Python 3. Okay, no, no, no. I was gonna make a point that this will give an integer answer, I quote, and F quote will give a float answer, but I forgot that in Python 3 it doesn't matter. Yeah, so you don't even need F quote. You could just do it right away, and it'll give you a decimal answer. So yeah, apologies for that. Um, yeah, so that's basic math, and yeah, that's pretty simple stuff, pretty universal throughout programming languages. All right, I'm gonna create x and y here. Over here, x equals, we'll do maybe 5. I feel like we shouldn't, I feel like I'm gonna do x is 2 and y is 4. Or we don't even, I'm just gonna use a and b actually. Yeah. Okay. So for the more difficult math, you have the floor method, the seal method, powers. There's two ways to do that, and square roots. There's also like two ways to do that. Um, so what you're gonna have to do is you're gonna have to import the math library in Python, and then you can use these methods. So what floor does, it basically finds it rounds to the largest. No, sorry, it rounds to the closest integer less than or equal to whatever is passed in. So I'll show you what that looks like. Um, let's find the quote of. Okay, actually, I'm not gonna do it under floor. I'm gonna right here. I'm gonna write quote equals a divided by b. Okay, and I'm gonna find the floor. Floored equals. I'm gonna call this something shorter. Floored equals math dot floor, and then you pass in whatever you want to floor. You don't really need the quote, but I don't know. I like my code readable. Um, 5 divided by 2 floored, and then I just pass in FLD, and then I just quickly want to show. Notice how the answer is 2.5. It floors it to 2, so basically, in essence, it just always rounds down. But seal, on the other hand, um, I'll just, should I call this seal? No, let's call it CIL. Equals math dot seal, and this will basically always round up in essence. So 5 divided by 2 rounded up, I'll basically say. That's basically what's happening. And I'll print that. And you can notice that it rounds up to 3 even though it's 2.5. Even if you passed in something like, I don't know, 1 divided by 3, which is like 0.3333333, it'll round up to 1, right? So, yeah, but I'm gonna change this to 5 divided by 2, so quote. Powers. So how to do powers in Python? There's two ways. So I'll do pow 1. The first way, let's say I wanted to raise, where is my variable? Raise a to the power of b, so 5 to the power of 2, which is 25. The first way is you don't even need the math library, and you just do two asterisks, so base and then exponent, and then I'll print out first way to do exponents. Um, and I'll do pow1. Okay? And then I'll call this one actual pow2. And then how you're gonna do this is you import the math library or call the math module and then write pow, and then you just pass in instead of you do sorry a's and exponent, and here I meant to do a and b, just so you can see kind of difference. And then I'm gonna print this. Second way to do exponents. I'm gonna do pow2. Okay, perfect. Okay, square roots. So square roots, uh, I'll just call it root equals. So let's say I wanted to find. I'm gonna create just a variable so it's nicer. Just call this in x. I'm gonna do x equals 4 just because then x is a perfect square. Or I'll do x equals 64. Um, so we all know that answer should be 8. So sqrt equals 8. This is a comment, so it won't run. Um, so how you can do this is two ways. You could either, if you have done exponents, you'll know that you can just do base and then use the asterisk and then do 1 over whatever kind of order of root you want to do. So there's actually different ways to do roots. So what you can do is basically if you want a square root, it's a 1 over 2. Cube root is 1 over 3. The fourth root is 1 over 4. Fifth root 1 over 5, and on and on. But we want to do a square root. And then you'll also notice that you can also do root 1 equals math.pow, um, sorry, x, and then 1 over 2. And then you could also, this only works for square roots in terms of roots. Like you can't use it for cube roots or anything, but the other way to do it is just do math.sqrt, stands for square root, and pass in the variable, and I'll just print out all three. Root, root 1, and root 2, and then I should write what this is so we know in the console what is going on. Um, Basically, this is the square root of 64. Write a comma right there, and yeah, let's run this. Okay, so the sum of 5 and 2, so this is basically our basic math. This is our more advanced math up to here actually. Okay, so you'll notice a few things. When we did POW1, it returned an integer because both of these values are an integer. Alright, but you could obviously cast to a float, and how you do a cast is what I've been doing this whole time. I don't know if I specifically said it, but you write float and put whatever you want to turn into a float into brackets, and that'll turn it into a float. Okay, and then but the math library basically always returns a float, which is a decimal floating point. I hope you guys caught on to that already. But yeah, floats have decimals. So the second way you can see over here, when you use math.pow, it had a point 0 on the end. And then this should be the, and the square roots of 64 is, we use the few ways we did it, so 8.0. Um, and why this is returning a floating point is because 1 over 2 is zero point 0.5, which is a floating point, and if one of the numbers in an operation is a floating point, the answer will also be a float, whether it's a whole number or not. Okay, math.pow returns a float anyways, but we're also using a float, and max dot square root is a is a method in the math library which will return a float. All right, this last one is not really something that like people use a lot, I'd say, but I feel like sometimes it's useful. So I'm gonna show it to you guys. So if you input fractions, and the fractions library basically allows you to simplify any fraction. So sometimes you might need to do that. I don't know when, but let's say I had some user input. Um, okay, so I could just be like, I'll do B and C, no, N and M. N equals int input, so I'm casting the string input to an int, and basically I'm gonna say enter the numerator, and then I'll just copy this, and then change this instead of N to M. Okay, and then what you can do is you can find simplified equals fractions dot fraction, and then you could pass in n and m, and this is denominator. I'm not sure if how you spell that, but the great thing about IntelliJ is that you can do spell check. So, few things about this fraction thing. So if I print it out simplified, I also want to print out the type of simplified to show you guys. Um, Simplified. So if you guys didn't watch the last video, type basically tells us what type of kind of data it is. Okay, so where I enter the numerator, I'll enter, I don't know, 5, and then I'll do 25. So you can see it prints out 1 over 5 as the fraction, and it's a fraction class. So yeah, you could turn that into a string, I'm pretty sure. Let's try that. Let's see what happens. str, so that's how you cast to a string. That's another thing you guys might want to know. And obviously, if you want float input, you just change this to float, and then yeah. So 5, 25, and we didn't do any print statements. That's why simplified, and then 5, 25. And you can see it turned basically the thing into a string. Anyways, that's it for today. I hope you enjoyed the video. Please like, comment, and subscribe, and thank you very much for watching.